Today, we're diving into one of the most elegant and honestly game-changing experiments in all of medical history. It's a story about how a surprisingly simple piece of hardware completely revolutionized our understanding of high blood pressure, and it led directly to treatments that save millions of lives every single year. So let's get into it.
Yep, that's right. No supercomputers, no fancy genetic sequencing, nothing like that. The key that unlocked one of the human body's most critical systems was just a small metal clamp.
And this number right here, this is why it all matters so much. We're talking more than 100 million people in the US alone who have high blood pressure. And a huge chunk of them are treated with medications that simply wouldn't exist without the story we're about to tell.
To really get the impact of this discovery, let's start with where we are today, in the modern world.
So if you know anyone on blood pressure medicine, there's a really good chance they're taking a drug from one of these two major classes, ACE inhibitors or ARBs. They are, without a doubt, absolute cornerstones of modern medicine. And they all work by targeting one very specific hormonal system in our body, a system that, less than a century ago, was a complete and total mystery.
To figure out how we discovered that system, we've got to go back in time, back to when doctors were staring down a real medical puzzle. Okay, so picture this. It's the 1930s, and doctors are seeing this clear pattern. Patients whose kidneys were failing often had dangerously high blood pressure. They knew there was a link, but they had no idea what it was.
This led to the ultimate chicken and egg question. Which one was causing the other? Was high blood pressure just destroying the kidneys? Or were sick kidneys somehow telling the body to drive up blood pressure? Answering this was absolutely critical, and it was going to take a brilliant experiment to finally settle the debate.
And that brings us to our hero, a pathologist named Harry Goldblatt. He designed an experiment that was just stunning in its simplicity and its power.
Goldblatt had this really clear idea. He thought, maybe it's not the kidney disease itself, but the reduced blood flow to the kidney that's the real trigger. He basically hypothesized that a thirsty kidney, one not getting enough blood, would release some kind of pressor substance into the blood to force the body's pressure to go up. And the way he tested this is just fascinating. This was 1934, remember. He took healthy dogs and simply placed a small adjustable metal clamp on the main artery that fed one of their kidneys. He then gently squeezed it shut, just enough to mimic what might happen in a diseased artery.
So he measured their blood pressure before and he measured it after. What do you think happened?
The result was immediate. It was dramatic, and it was conclusive. The dogs developed sustained, severe high blood pressure. Goldblatt had proved it. A kidney starved of blood could, all by itself, cause hypertension. The chicken and egg problem? It was solved.
Okay, so this was a massive breakthrough. But you know how science works. It opened up a brand new question. What was this mysterious pressor substance the kidney was letting loose? The next mission was to map out the entire biological mechanism.
And this is the incredible chain reaction that scientists eventually uncovered. Think of it like an alarm system. First, the kidney senses low blood flow. The alarm goes off. In response, kidney cells release an enzyme called renin. Renin then kicks off this domino effect that creates a super potent hormone called angiotensin II. Now, this hormone does two big things. It powerfully squeezes blood vessels all over the body, and it tells the kidneys to hold on to salt and water. And what do both of those actions do? They drive blood pressure way, way up. This entire elegant mechanism became known as the renin-angiotensin system.
Goldblatt's work also gave researchers these fantastic new tools to dig even deeper. Let's look at the two big ones. First, you have the one-clip, two-kidney model, or 1C2K. You clamp one artery, but you leave the other kidney totally healthy. This showed us a type of hypertension that's driven purely by that renin hormone. Now, compare that to the one-clip, one-kidney model, 1C1K. Here you take one kidney out and clamp the other one. In this case, the body can't get rid of extra salt and water, so the high blood pressure becomes what we call volume-dependent. These two models were absolutely essential for understanding the different ways kidney problems can cause high blood pressure in humans.
So here's the key takeaway, the big so what. There is a direct, unbroken line that connects that simple experiment with a clamp back in 1934 to the pills in millions of medicine cabinets today. Let's pull it all together.
So Goldblatt's impact was really threefold. One, he definitively proved the kidney could cause high blood pressure. Two, his work led straight to the discovery of a major hormonal system that controls our blood pressure. And three,
He created an invaluable experimental model that scientists still use to study human diseases and develop new drugs.
You can just see the progression so clearly laid out here. Goldblatt's experiment in 34 kicks everything off. Then, over the next few decades, scientists fully map out the system. And then comes the pharmaceutical breakthrough in the 1980s, the creation of drugs that could specifically block this system. And those, of course, are the ACE inhibitors and ARBs we rely on today.
This quote just sums it all up perfectly. By clamping a single artery, Goldblatt established the kidney as a master regulator of blood pressure. And in doing so, he gave modern medicine a brand new target for treatment.
It's really an incredible story of scientific insight. And it makes you wonder, doesn't it? What other huge, profound truths about our bodies and our world are just waiting to be uncovered by the next simple, elegant experiment?